Hello students. Today we are going to solve one more problem from Doppler effect, and this question is asked basically in IIT JAM 2015. So in that question, they provided that the speed of blood in vessel can be measured by using Doppler effect. Okay. So also they have given that there is a blood cell. There is a blood cell. Okay. Okay. It is moving in this direction with speed VV. Okay. And there is a source of sound that is also moving in the same direction as the motion of the blood. Okay, and that frequency of this source is given. F is given as 1.0522 megahertz. Okay, and when that sound is reflected from this blood cell, then it produces beat of 100 hertz. Okay. Also, the speed of sound they have given, that Vs, that value also given on 545 meter per second. Okay. So you have to calculate that speed of this blood cell in the vessel, that you have to calculate. So again I am repeating. So they have provided that speed of blood cell in the vessel can be measured with the help of Doppler effect. Also they uh, gave that information. So there is a source of sound, or there is a sound source having frequency 1.0522 megahertz is moving. The sound is moving in the same direction as blood cell. Okay, and when this sound is reflecting from blood cell, then it produces that beats, that is 100 hertz. Okay, so you have to calculate from this concept. You have to calculate that speed of blood cell. Okay. Okay, so let us solve this question. So there will be two cases. First, so you have a source. First case, you have a source. Okay, so let us denote like this. Case 1. Case 1. So you have a source of sound having frequency f. F also they have provided. Okay, okay, and its speed of sound in blood cell also they have given. Okay, and you have a blood cell that is actually first time, in first case it will be observer. Okay, this source is stationary and it emits sound. It is moving in the same direction as the motion of blood cell. Blood cell is moving in this direction with speed Vb. Okay, so blood cell itself this time as an observer. So observer is moving away from the source. Source is stationary. Okay, so frequency observed by this blood cell or observer f dash will be how much? Since the observer is moving away, so I can write formula like original frequency into speed of sound in blood cell or in vessel minus Vv divided by Vs. Okay, so this is the case on. This much frequency will be noted by blood cell. Okay, now case 2. Now you have case 2. Second case, you have a blood cell. Blood cell is moving this direction with Vv. Okay, and this sound will come here, it will be reflected back. So this blood cell will act as a source. Will act as a source because that sound is reflecting from this blood cell, and you have an observer here. In case 2, you have an observer here. So it is like observer is stationary and source is moving away from this observer, and that source is emitting frequency. That frequency will be how much? That will be f dash. So now observer will note the frequency for this case. That will be how much? That will be f double dash. F double dash will be how much? You see that source is moving away, so I'll use original frequency or source frequency is how much here? F dash into Vs divided by Vs plus Vb. Why plus? Because source is moving away from the observer. Now I'll substitute this value of F dash. So we know that F dash is how much? F dash is original frequency F into Vs minus Vb divided by Vs, and you have Vs by Vs plus Vb. This Vs will be cancelled, and I'll get F into Vs minus Vb divided by Vs plus Vb. Okay. So this F double dash frequency will make bits with original frequency F. So what I'll write? I'll write delta F. Delta F equals to 100 equals to actually F minus F double dash. Okay. And I'll substitute the value. So it will be F into Vs minus Vb divided by Vs plus Vb. Okay. So if you further rearrange it, you will get F into 2 Vb divided by Vs plus Vb. Okay. So it means Vs plus Vb divided by Vb, that will be how much? 2f by delta f. 2f by delta f. So I can write like Es by Vb equals to 2f by delta f minus 1. So it means Vb, the speed of blood cell in vessel will be Vs by 2f by delta f minus 1. And everything they have provided. Vs, that is given, that value is basically 1545 meter per second. That is the velocity of sound in vessel into the frequency of this sound that is given, that is 1.0522 megahertz. So it will be 10 to the power 6 hertz, right? 10 to the power 6, this will be. And you have delta, that is delta f, that is bit, that is 100 and minus 1. Okay, so if you calculate it, basically you will get 0.07 meter per second. Okay. So according to that given option, that value was close to 0.01. So whatever option they have given, that was this value was close to 0.01. So according to given option, correct option will be 0.01 meter per second. Okay. Thank you.